Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay, the question says that a ball is projected upwards from the top of a cliff of height 24 meters. The initial velocity of the ball is 25 meters per second. Then the question says, calculate the velocity at which the ball strikes the ground. Okay. Let us look at the data here. They want the velocity, so they want the final velocity. What do you have? We have the initial velocity of the ball, which is 25 meters per second. The ball is projected upward, so G is going to be negative 9.8 meters per second squared. Yeah, what else do we know? Yes, we know delta x. Like I said before, let us repeat it again. If a ball is projected upwards, it goes upwards, reaches maximum height and comes and passes the point of projection. This displacement covered here is 0. Why is 0? Because the ball went up, probably displacement x, and came back, which is displacement negative x. So when you sum them up, you'll have 0. So which means that the only displacement this body covers is this one. And that's the height of the cliff, which is 24 meters. But you have to recall that this point is below point of projection. This is the point of projection, which means that for point of projection, if you take upward positive, this one is going to be positive, and the below point of projection is what? Negative. So our displacement is going to be negative 24 meters. Now with this information, what is the next step? Next step is to have the right equation. And the right equation for this one is going to be Vf squared is equal to Vi squared plus 2a delta x. Okay, Vf is wanted. So it's going to be Vf squared is equal to 25 squared plus 2 times negative 9.8 times negative 24. Let's see what we get here. So you end up with 470.4. Next is to find the square root of that. Okay. What do we get here? We're going to get Vf equals to 33.10 meters per second. So that is the velocity at which the ball strikes the ground. Yeah, then we come to this question. It says that after striking the ground, the ball bounced to a height of 18 meters. And says calculate the velocity at which the ball bounced. Okay. So let us look at here. the ball hit the ground and it bounced. So what do we do? We are going to look for the initial velocity of the bounce. But we know the displacement covered, which is 18 meters. Okay, so the ball was going upwards and the displacement is upwards, so it's positive. What else do we know? The ball is going upwards, so G is negative 9.8 meters per second squared. Okay, and they said maximum height. At maximum height we know VF, and VF is 0 meters per second. So from here, what do? You look at the data and decide on the formula to use. The formula is going to be VF squared is equal to VI squared plus 2A delta X. Okay. So what do we have as VF squared? Is 0 squared. And the VI is wanted, which is times 2 times negative 9.8 times displacement, which is 18. So from there, what do? So on simplifying, you get 0 is equal to VI squared plus negative 352.8. And from there, what are you going to say? You're going to say 352.8 is equal to VI squared. When you find the square root, you get your VI as 18.78 meters per second. Yeah, there we are. And with that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe. It's me, Richard, here. Bye-bye.